Hello, my dear first grade students. I am Mr. Ahmed Magdy, your math teacher. Our lesson today is the fourth and fifth lessons of the second unit of the fifth grade curriculum of the academic year 2024-2025. Today we will talk about prime factorization for any number to find the prime factors of this number. And what is the difference between prime numbers and composite numbers? How to know the number from the product of its prime factors, and how to reach the greatest common factor GCF between any two numbers in more than one way. So let's go. The first part with us today is how to factorize a number to find its prime factors. But we want to know first, what is the difference between prime number and composite number? Prime number is a whole number that has exactly two different factors, one and the number itself. So if I want to find the factors of 2 has only two factors, 1 and 2. 3, its factors are 1 and 3. And 5 the same, and 7 and 11 and 13 and 17 and so on. All of these numbers are prime numbers. All of these numbers have exactly two different factors, 1 and the number itself. But the composite number is a whole number that has more than two factors, like 4 has 3 factors, 1, 2, and 4. 6 has 4 factors, 1, 2, 3, and 6. But what is the factors? The factors that the timetables which the number 6 is inside the table. So 6 is inside the timetable of 1 and 2 and 3 and 6. Okay? And we have also 9. 9 has 3 factors, 1, 3, and 9. 12 has 6 factors, 1, 2, 3, 4, 6, and 12. All of these numbers, we call them composite numbers because they have more than two factors. Okay, so if I have numbers like this and I want to know the difference between prime and composite. Okay, so 2 as example is prime or composite. 2 is prime, okay, because it has two factors. 4 is composite because it has 3 factors. Okay, 29 is prime because it has 2 factors. Okay, 3 is prime because it has 2 factors. 5 is prime. 6 is composite because it has 4 factors. 7 is prime. 11 is prime. So prime numbers have 2 different factors. Only 2 have different factors. Composite number have more than 2 factors. Okay, this is the difference between prime number and composite number. Next, I want to factorize number or write a number as a product of prime factors. Every composite number has been written as a product of its prime factors, and this product is called the prime factorization of the number. So we can use the factor tree to find the prime factorization. So if I have an example like this, I have 24 and I want to write 24 as a product of its prime factors, or I want to prime factorize it. Okay, so I have three forms as a prime factorization for this number. The first one here, I have 24, and 24 equals 2 by 12, but 2 is prime and 12 is composite, so I will factorize 12 again. So 12 is 3 by 4. 3 is prime and 4 is composite, so I will factorize 4. 4 is 2 by 2. So the prime factors here is 2 by 2 by 3 by 2 by 2. Okay? Here, 24 equals 4 by 6. And 4 is 2 by 2. And 6 is 2 by 3. So the factors here will be 2, 2, 2, and 3. Okay? Next, I will factorize 24 as 3 by 8. And 8 is 2 by 4. And 4 is 2 by 2. So it will be 3 by 2 by 2 by 2. All of these forms is the same factorization for the same number. Okay? And they give me the same prime factors. 2 by 2 by 2 by 3. So the prime factorization of 24 is the product of all these prime factors. Okay? So if I wanted to factorize these two numbers, I have the first one here, 20, and the second one is 18. He made the first step. So he asks me 20 is 2 by what? 2 by 10. So here I have 2 is prime number and 10 is composite. So I will factorize 10. 10 is 2 by 5. And I will stop here. So 20 is 2 by 2 by 5. So I will write 2 by 2 by 5. Next I have 18. He made the first step. He asks me 18 is 3 by what? 3 by 6. 3 is prime number and 6 is composite, so I will factorize 6. 6 is 2 by 3. So I will write as a prime factorization is 3 by 2 by 3 or 3 by 3 by 2. Okay? Next, I want to factorize these numbers. I have 36, 28, and 48. The first one here is 36. So 36 equals what? I have 3 by 12, 6 by 6, 4 by 9. All of these numbers is a product or the factorization of 36. Okay? So I will say 6 by 6. Okay? So 6 is 2 by 3 and 6 here is also 2 by 3. 2 is prime, so I will put a small circle here, and 3 is prime, and 2 is prime, and 3 is prime. So I will put a circle up around the prime factors only. Okay, so the prime factorization here will be 36 equals 2 by 3 by 2 by 3. And this is the first number. The second one here I have 28. So 28 equals what? I have 2 by 14, 4 by 7, and 1 by 28. Listen carefully at this point. Do not use 1 as a factor for any number. Okay? So delete 1 in the prime factorization. Okay? So I will use 2 by 14 or 4 by 7. So I will use here 4 by 7. Okay? 4 is composite and 7 is prime. So I will put a circle around 7. So 2 equals 2 by 4 equals 2 by 2. And I will put a circle here and here. So the prime factorization of 28 equals 2 by 2 by 7. And this is the second number. The third number here is 48. 48 equals what? I have 2 by 24, 4 by 12, 6 by 8, and 3 by 16. So I will use the easiest one. So I will use 6 by 8. Okay? 6 equals 2 by 3. And 2 is prime and 3 is prime. Next I have 8 equals 2 by 4. And 2 is prime. So I will factorize 4. So it will be 2 and 2. Okay? So I have here 2 and 2. So the prime factorization of 48 equals 2 by 3 by 2 by 2 by 2. Okay? Next. The second part here is about how to reach the number or know the number by multiplying its prime factors. Okay? And I want also to find the remaining factors of this number. So I have an example like this here. 12. 12 equals 2 by 2 by 3. So it will give me this form and I want the number. Okay? So I will say 2 by 2 equals 4 and 4 by 3 equals 12. So the number is 12. Okay? But I want to find the other factors of 12. Okay? So I will use the listing method to find all factors of 12 and I will delete the prime factors to find the non-prime factors. So here I have 1, 2, 3, 4, 6, and 12. So I will delete 2 and 3. So the remaining is 1 and 4 and 6 and 12. So the non-prime factors is 1 and 4 and 6 and 12. Okay? So if I have a factorization like this and I wanted to find the number, okay, I wanted to find the product of the prime factorization here and I wanted to list the all other factors of the product. So the first one here is 2 by 2 by 7. 2 by 2 equals 4 and 4 by 7 equals 28. So the first one here is 28. And I want to find the other factors of 28. So the factors of 28 is 1 by 28. And I have 2 by 14. And I have 4 by 7. Okay? But here I have 2 and 7. So I will cancel 2 and 7. Okay? So the other factors is 1 and 4 and 14 and 28. Okay? Next I have 2 by 3 by 5. 2 by 3 equals 6. 6 by 5 is 30. Okay? So I wanted to find the factors of 30. 30 equals what? Equals 1 by 30. Next I have 2 by 15. Next I have 3 by 10. Next I have 5 by 6. So I have all factors of 30. Okay? So I will delete the prime factors. I have 2, 3, and 5. So 2 will be cancelled, 3 will be cancelled, and 5 will be cancelled. So I have 1 and 30, 15, 10, and 6. So the other factors is 1 and 6, 10, 15, and 30. Okay? Next I have 2 by 2 by 2 by 3. So The third one is 2 by 2 is 4 and 2 by 3 is 6. So 4 by 6 is 24. Okay, so I wanted to find the factors of 24. So I have first 1 by 24 and 2 by 12 and 3 by 8 and 4 by 6. Okay, so I will delete the prime factors. I have 2 and 3. Okay, so the other factors are first I have 1 and 24 and 12 and 8 and 6 and 4 and 6. So I have next 4, 6, 8 and 12 and 24. Okay, so we knew how to find the product of the prime factorization listed, and we can find the other factors of this product. Okay, next I want to find the greatest common factor for any two numbers using the prime factorization and also using the listing method. Okay, so I have two ways to find the greatest common factor. So I have an example like this. I have 18 and 24 and I want to find the greatest common factor between the two numbers of the two numbers. Okay, so the first method is to find all the factors of the two numbers. Okay, so the first number here is 18. So 18 equals 1 by 18, 2 by 9, 3 by 6. Okay, so I have 6 factors: 1, 2, 3, 6, 9, and 18. Next, I have 24. 24 equals 1 by 24 and 2 by 12, 3 by 8, 4 by 6. So I have 1, 2, 3, 4, 6, 8, 12, and 24. 1, 2, 3, 4, 6, 8, 12, 24. So I will search about the common factors between the two numbers. I have here 1 and 2 and 3 and 6. So the common factors here are 1, 2, 3, 6. Next, I will search about the greatest common factor. Here I have 6, the biggest number in the common factors. Okay, so 6 is the greatest common factor. Okay, this is the first method. We can use the prime factorization for the two numbers and find the greatest common factor. So listen to me carefully at this point. So I will factorize the first number here, 18. So 18 equals 2 by 9 and 9 equals 2 by 3, 3 by 3. Okay, so next I have 24. 24 equals 3 by 8 and 3 is prime, 8 is not prime, so I will factorize it 2 by 4. 4 equals 2 by 2, so I have 3, 2, 2, and 2. So I will write the two numbers under each other like this: 18 and 24. The first one equals 2 by 3 by 3. Okay, next I have 24 equals 3 by 2 by 2 by 2. I will write 3 under 3 here. So I will write 3 right here. Next I have 2. So I will write 2 under 2 like this here. Okay, next I have two twos, but I don't have any twos in the first number, so I will write the two twos after 3, so it will be like this. Okay, so I will search about the repeating factors in the two numbers. So the first one here is 2 and the second one here is 3. So I will multiply 2 by 3, okay, to find the greatest common factor. Okay, so 2 by 3 equals 6, so the greatest common factor is 6. Okay, let's try one example like this. I have 4 and 6 and I want to use the listing method. So first I wanted to find the factors of 4, so I have 1, 2 and 4, because 4 in the timetable of 1 and 2 and 4. Next I have the factors of 6, so it will be 1, 2, 3 and 6. Okay, so I will search about the repeating factors or the common factors. The first one here is 1 and the second one here is 2. Okay, so the common factors here is 1 and 2, so the greatest common factor is the biggest number here, so I have here 2, so the greatest common factor is 2. Next I have 10 and 30. So the first one here, the factors of 10 in the timetable of 1 and 2 and 5 and 10. 30 in the timetable of 1 and 2 and 3, because 1 by 30. Okay, 1 by 30, 2 by 15 and 3 by 10, and next I have 5 by 6. 1 by 30, 2 by 15, 3 by 10 and 5 by 6. I will search about the common factors between the two numbers. So I have the first one here is 1, and next I have 2, next I have 5, and next I have 10. Okay, so the common factors are 1, 2, 5 and 10. Okay, so the greatest common factor will be the biggest number in the common factors, so it will be 10. So the greatest common factor is 10. Next, I want to factorize the number and find the greatest common factor. So I have here 60 and 45. So he tells me to factorize 60 and 45 to their prime factors, then find the greatest common factor. So I will factorize 60 to 6 by 10, because 6 by 10 equals 60, and 6 equals 2 by 3, and 10 equals 2 by 5. So the factorization of 60 is 2 by 2 by 3 by 5. Okay, next I have 45. 45 equals 5 by 9, and 5 is prime, so I will stop here. 9 is 3 by 3, so it will be 5 by 3 by 3. So 45 here equals 5 here, 3 under 3, and 3 alone in one column alone. Okay, next I will search about the repeating factors or the common prime factors. So I have here 3 and 5. Okay, so the greatest common factor is 3 by 5. So 3 by 5 equals 15. So the greatest common factor is 15. Next, I want to find the greatest common factor of 36 and 54. And he didn't tell me which method I have to use. Okay, so let's try the factorization first, and after that we will use the listing method. First, I will factorize 36 and 54. 36 equals 6 by 6, and 6 equals 2 by 3, and 6 equals 2 by 3. So 36 equals 2 by 3 by 2 by 3. Next, I will factorize 54. 54 equals 6 by 9. So 6 equals 2 by 3, and 9 equals 3 by 3. So I have 2, 3, 3, and 3. And here I have 2, 3, 2, and 3. So I will write 54 equals 2 under 2, 3 under 3, 3 under 3, and 3 is alone in one column. So it will be 2 by 3 by 3 by 3. So the greatest common factor here is I have 2 as common factor and 3 as a common factor, and also I have another 3 like this. So it will be 2 by 3 by 3. So it will be 18, because 2 by 3 equals 6 and 6 by 3 equals 18. So the greatest common factor between 36 and 54 is 18. Okay, if I want to use the listing method, so I will search about the factors of 36 and 54. So first, I want the factors of 36. So it will be 1 by 36, 2 by 18, 3 by 12, and 4 by 9. And I have 6 by 6. So I will write just 1 6. Okay. 54, I have 1 by 54, 2 by 27, 3 by 18, 4, no, 5, no. I have 6 by 9. Okay, so it will be 1, 2, 3, 6, 9, 18, 27, and 54. Okay, so the first common factor, I have 1 and 2 and 3 and 6 and 9 and 18. So the common factor is 1, 2, 3, 6, 9, and 18. So the greatest common factor will be the biggest number, so it will be 18. Okay. Next, I want to factorize every number and find the greatest common factor. The first one here I have 45, and the second one I have 63. The first one here, 45 equals 5 by what? By 9. And 9 is 3 by 3. Here I have 7 by 9. And 9 is 3 by 3. So the first number 45 will be 5 by 3 by 3. And the second number 63 will be 7 by 3 by 3. So I will write 3 under 3 and 3 under 3 and 7 in one column alone. So it will be 3 by 3 by 7. So I have two prime factors are repeated in the two numbers like this. So it will be the greatest common factor is 3 by 3, and 3 by 3 equals 9. So the greatest common factor is 9. Okay, and with that we ended our video today, in which we explain how to factor a number to its prime factors and find the greatest common factor between two numbers. I hope people understood our lesson today, and I hope that you solve many exercises in this lesson so that we can understand more. So if you have any questions, send them in the comments. Don't forget to like and share the video with your friends and subscribe to my channel. I will see you in a new video and new lesson. I'm Mr. Ahmed Magdy. Goodbye.